All right, we're back with some warm water. What we need is warm water to activate the yeast. I put a tablespoon of yeast into this cup, and I'm going to put in 3 tablespoons, maybe just a little more, of warm water. And I didn't bring the proper things with me. I'm gonna stir this up, and this is going to actually, you can do this for me. Just keep stirring that. That's gonna activate the yeast. That needs about between 30 seconds and a minute to happen. I know it's getting pasty. Just keep mixing it up as best you can. Swirl it around. All right, now what I'm gonna do is in a container, I'm gonna put some hydrogen peroxide. Hydrogen peroxide comes in a brown container because hydrogen peroxide is H2O2. There's an extra oxygen atom on here, and that is not very stable, so it wants to come off. And that's a very slow process. Light speeds that up, but even that is not fast enough for what we're looking for. So I'm measuring a half a cup of peroxide. Whoa! And I'm gonna put that into my container here. There we go. And gonna put some dish soap in here. A healthy squirt. And I'm gonna mix that up. Now I'm gonna make my lava color. So Oliver, I'm gonna put some yellow in here. And I'm gonna put some red to make this orange, right? So that it looks like lava. Mix it together. Okay, so in here I've got soap, hydrogen peroxide, and food coloring. I'm gonna take this mixture that Marshall made that is too thick, I should say. Yuck. I need more liquid. I gotta get it to pour in there. And let's see what happens, guys. It creates lava. So Oliver, if I had some Play-Doh or clay, I could make it around the bottle. Now, that's a good question. Can you touch that? You can in this experiment because it is not.
I can.
So out here, the temperature is 17.8 degrees.
That feels.
Let's put this in and see what does the temperature say now. Look at that, it's going up. So that other experiment was endothermic. It got cold. This experiment is exothermic, which means it gives off heat. It creates more energy than it needs, so it gives that off in the form of heat.
I'm gonna go watch
All
this
right,
stuff.
that's a good idea.
Yeah.
All right, so inside these bubbles is oxygen gas. Oxygen is highly flammable. So am I crazy for doing this? I am. Not. We're gonna make a big explosion, a big fireball later. That's not how you would do it. Okay, so that was cool, Oliver. Again, if I had some Play-Doh or clay and I made a mountain around this bottle, you could do that to make it look like lava. Pretty cool, huh? All right. That's a volcano. Let's make a geyser. Let's get crazy and make this really big, all right? I am going to put in a lot more than I did before. Okay, let's do this. All right.
Go big or go home.
That is a lot of hydrogen peroxide.
Go big or go home.
Okay, we're gonna put some soap in here. I'm not gonna put food coloring in because that's not the point of this one. This is just to see how much of a fountain we can make. Here is a lot of yeast. Okay. While I'm mixing this, I will talk to you guys. So, the reason this experiment works is hydrogen peroxide has an extra oxygen atom on it that wants to come off. We can speed that up by putting in this yeast. Yeast is a living thing, as I said. It makes a enzyme called catalase. Catalase breaks hydrogen peroxide down into water and oxygen very quickly, which you can see by that first experiment. Okay, this is really going to happen. So, I would stand back, Julia. I have no idea how big this is going to get, guys, so let's check it out.
What about food coloring?
We're not going to do food coloring this time. This is just to see how big of a reaction we can get. Oh, bummer. I was hoping it was going to shoot way up into the air. But that is going to create a lot of foam that, again, feels warm because it's an exothermic reaction. Sure, you can touch it if you want. And that is safe to touch, guys. That is no longer hydrogen peroxide, that is water. Hydrogen peroxide is caustic, so you want to be careful with it, but now it's just soap and water. All right, last one we're gonna do, guys, and this is really, hopefully gonna be the one that is super fun, buddy. No, thank you. All right, ready? As I said, oxygen is flammable, but not when it's surrounded by soap. So, we're going to do this experiment one last time, but I'm not going to put soap in it. Now I just want the oxygen. Put this in here, put some of my warm water, mix it around. I need my peroxide again. And my funnel. Alright, so this is what I have done. I've attached a plastic bag to a hose. That hose is going into the bottle where I'm going to put this again, this reaction inside the bottle. The top here is made out of Play-Doh. I had to improvise and come up with a way to keep that gas from spilling out. I want it to go right into that bag. And then we're going to try to make that gas catch on fire. All right, let's let that sit for 1 minute. I'll take off my stopper. You know what, I'm just going to estimate it this time. I want to get a lot of oxygen, so I'm actually going to put in a little more than before. Okay. Let's see if this works. Whoop. Okay, here we go. Oh no. All right, guys, that is not gonna work. I am sorry. I did not have enough of the materials to practice this, so that is a huge bummer. This bottle should have been bigger. I would have been able to collect all this gas. I was gonna put it on my grill. I had a sparkler on a stick ready to ignite it from far away. That makes me sad. Anyway, I hope you had fun watching the elephant toothpaste and playing with baking soda and vinegar. Again, if you want to try that at home, you can. However, those materials are kind of scarce right now. So, anyway, thanks for hanging out with me. Please stay safe and have fun. Remember, science is awesome and so are you. Bye-bye.